Hello folks, welcome to Unit 3. We're going to do quadratic functions today for grade 11 math. Let's get started with 3.1. So 3.1 is just basically starting off with quadratic functions in vertex form. I'm going to show you what a quadratic function is, and let's talk about some concepts and then jump to some examples in order to get those applied. Alright, so what exactly is a quadratic function? If you remember from grade 10, anything with a power, so a polynomial, okay, so a quadratic function is basically a polynomial with the degree of 2. So what does the word degree mean? If you remember your polynomials, if you have 2x squared plus 3x minus 3, the power on the x is known as your degree, okay? So the highest power on your x is usually known as your degree. So when you're talking about quadratic functions, the highest power of your x has to be 2. So for example, you can have something like 3x minus 4x squared plus 2. So again, this is not arranged properly where you're starting off with the highest degree, but as long as you see that x has a power of 2, that's the highest, this would also qualify to be quadratic, okay? However, if you see something like 3x cubed minus 4x squared plus 3, that is not a quadratic. And that's because the degree is 3 and not 2. Okay, because 3 is the highest power of x and not 2. So that's how we identify what a quadratic function is. Okay, so quadratic functions have a degree of 2. Now, let me show you something. When you graph a very simple quadratic expression, which is y equals to x squared, okay, this is the most simple version of a quadratic equation. This is going to be your Cartesian plane. This is your origin 0, 0. Your x squared always sits like this. Okay, so very simple graph, and this is the basic quadratic graph. And the reason you need to know this is because going forward in the unit, we're going to use this graph and see how our equations are changing based on the shape of the changing graph, okay? So for example, let me just show you how to do that on a graphing calculator if you want to see how to neatly graph it out. So let's say y equals to x squared, and then you hit graph on that. So this is how it looks like, okay? So it's basically where your vertex is at the 0, 0. Vertex is the lowest point on that graph, is going to be on the 0, 0, okay? That's what your graph should look like. Now another thing that I want you to notice is that when you have a positive x squared, you open your graph upwards, okay? So the graph opens up. However, if you have y equals to negative x squared, where your value here is a negative, you'll have exactly the same graph, except it's going to open downwards like that, okay? So the graph opens down. So these two things are very important. Now, how do you translate that? So in standard form, a quadratic equation is written as ax squared plus bx plus c, okay? When your a is positive, you open the graph up. When your a is negative, you open the graph down, like I just showed you here. Okay, so I guess put that in your notes, is that when a is positive, your graph opens up, and when your a is negative, not just negative 1 or positive 1, it could be like negative 2, negative 3, anything that's negative, okay? Your graph will open down. Okay? So I need you guys to understand that. The next thing I need you guys to understand is that the center point of that graph right here is known as your vertex, okay? So this point, so basically this point here is known as your vertex. Now there's something called the axis of symmetry. So because this is a parabola, that's the shape of this graph, any line that divides the parabola in equal halves, so it looks like you're looking at a mirror, almost. That was an ugly line, I apologize for that. So basically that is your line of symmetry, okay, your axis of symmetry, because it's dividing your parabola in two halves, just like you're looking at each other in a mirror. So if you look at this graph right here, you can see that the vertex is happening at 3, 1. And basically the axis of symmetry is happening at x equals to 3. So the equation of the axis of symmetry is always written as x equals to 3, which is the x coordinate of your vertex. Okay, and see how this side of the graph is basically symmetrical to this side of the graph, and that's what the line of the axis of symmetry is supposed to do. Alright, so here's another concept that you need to know. So if your graph is opening up, your vertex makes a minimum point. Okay, this is going to be your minimum. If your graph opens down, this point, the vertex, is going to make a maximum. Okay, obviously, because if you're looking at a parabola, that's your maximum point. If you're looking at this parabola, this is your minimum point. Now, the question will always ask you, so for example, if you look at this vertex right here, so this is opening up, which means we're forming a minimum. So if I ask you what is the equation or what is the minimum, you're always expected to answer as y equals to 1. Okay, so your answer is always supposed to be for this. And the reason behind it is because we're looking at the height of the graph and the minimum is happening at y equals to 1. So if this graph were to open downwards like this, say for example something like this, then you would say that the maximum is occurring at y equals to 1. Okay, so anytime they ask you what the minimum is or what the maximum is, take the y coordinate of your vertex and put that as an equation form saying y equals to that. And if they ask you for the axis of symmetry, obviously take the x coordinate of your vertex and put it as x equals to 3. So keep that in mind when it comes to writing equations. These are some forms that you need to know. So quadratic equations can be expressed in standard form, which is ax squared plus bx plus c. In factored form, so if you remember from grade 10, your quadratics can be factored as a number, like a coefficient, and then x minus r and x minus s. And the vertex form is written as this. We will dive deeper into all these forms as we go forward in the next unit, in the next section I meant. So these are the basics of quadratics. So let's go ahead and do some examples and see how we can apply them.